We are on 6.9. We're going to take what we know about exponential applications, about exponential functions, and we're going to apply it to real life scenarios. So far we have worked with this equation. Today we have a new equation in a new form, this one. In both of these, the y is your dependent variable, it's your range, it's your total, your new total basically. Where A, in both cases, you can see the A is the same also. A is your initial amount, what you begin with, which is also your y-intercept. Now you see some differences here. This one has 1, this means plus or minus r. You pick one. You pick plus or minus, you don't put them both in. And this one has B. So we already learned that B was our factor, our growth or decay factor, and that B is greater than 1 for growth and between 0 and 1 for decay. So R is our rate of growth or decay. You use R when it's a percentage, and you have to convert that percentage to a decimal. Now I said plus or minus. You use plus when you have growth. You use minus when you have decay. Now the x is the exponent and the t is the exponent. T stands for time. And x, they both stand for the number of times that it grows or decays. How many time intervals occur? All right, let's look at an example. The population of a small town tripled, there's your factor, every year. If the population in 1920 was 87 people, what was the population in 1932? Since there is no percentage, we use the AB to the X with a factor. So we're looking for Y, our new total. Our initial population was 87 people. It tripled, that means times 3, so my factor is 3. It tripled every year for how many years? From 1920 to 1932. That is 12 years. So we put to the 12th power. Then you're just going to type that in, just exactly like that, to either your calculator or Desmos, and you're going to get this huge number. That's a lot of people because it's exponential, so it increased exponentially. So it is 46,235,367. Since we're talking about population or people, if there were a decimal, you just chop it off because we go to a whole number when we have people. Obviously, this is not a realistic scenario, but that's how you would do that problem. Tractor has a depreciation rate. That means it loses value. So this is decay. The one above was growth. This one's decay. Now it's a percentage rate, so we're going to use this equation. 1, since it's decay, we're going to do minus R to the T. What's your original value of your tractor? 29,000. 1 minus. Now you have to take this percent and convert it to a decimal. So we go 19 divided by 100 and we convert it to 0.19. It depreciates per year for 5 years. So your exponent is 5. And then you would just type this into your calculator, exactly like this, parentheses and all, with an exponent of 5. And you would get that it now, 5 years later, is valued at 10,112. Now, I just rounded to the nearest dollar because if I'm selling a tractor, I'm certainly not going to ask for the cents. Probably wouldn't even ask for the $12, but I'm not going to take off for what you round to. Let me show you one other thing. Sometimes you're going to see this equation where they went ahead and did the subtraction for you. Instead of writing out 1 minus 0.19, they might go ahead and say 0.81 because they went ahead and did the subtraction. So be aware of that. And then let's look at this one. You're going to invest $1,000. Therefore, it's growth. You're earning interest. It's a percent, and it's growth, so you're going to use 1 plus. You're going to be carefully convert that to a decimal. If you're unsure how to convert a percent to a decimal, you divide by 100 on your calculator, and it will move the decimal for you. Okay, it does this every year. You accumulate interest every year for 4 years. So you do the exponent of 4. And after 4 years, you have $1,238.82 in your account. And yes, I want the bank to give me my cents. Once again, it is a possibility that you might see this like this, where they went ahead and added. They just took out the plus sign and added. Let's look at one on the next page. Let's look at this one. It says D for some reason. TJ posted a video of himself doing basketball trick shots. The number of views grew at an exponential rate. You can tell it's growth. How many views did he receive the first day? Well, that's your initial amount, your y-intercept. Now, it isn't thousands, so 10,000. About what percentage is it increasing? All right, this looks like it would be really hard to tell. However, there's an easy way to find out. Since it's exponential, it's multiplying, and it's growth, it's multiplying each time. So to find out what it multiplied by, take your y value here. So this is the 0.115. This is the 0.010. Take your y value and divide by the y value just ahead of it. So we're going to go 15 divided by 10. That's going to be 1.5. So if my rate were 1.5, that would be like saying 1 plus 0.5. So what is the percentage it's increasing? 50%, because 0.5 as a percentage is 50%. This time we would multiply by 100 to go the other way. According to the graph, he thinks the video receives 5,000 additional views each day. Is this correct? Well, the first day it increased by 5,000. But the second day it increased by more. If it increased 5,000 every day, that would be linear. Linear increases by the same amount each day. Exponential multiplies, so it's increasing exponentially more every day.